Good morning. Today we are going to work on the practice test for chapter 10. Now, just a reminder that you want to be able to work them out by yourself first and then come back to the YouTube video to see if you made a mistake or to double check your answers. But you want to be able to work them out first so you can process through each of the steps of each problem. But let's go start with number one. On number one, we have use the binomial theorem to write the binomial expansion of x minus 4 to the fifth power. This is to the fifth power, so we need to be able to use the Pascal triangle to be able to find the fifth row. I'm not doing a separate piece of paper. We're going to start with 1, 1, 1. This is 1. Add those two numbers. 1 and 1 is 2, and then 1. Gives me 1. 1 plus 2 gives me 3. 2 plus 1 gives me 3. Then 1. Start with the 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And this is 1. This is the fourth row. 1, 4. Let's do one more. 1 gives me 5. 4 plus 6 is 10. 10, 5, and 1. I'm not going to use this row for my expansion, which is 1, 5, 10, 10, 5, and last will be 1. Now I'm going to continue with the value of A. A in this case is just x, so we have x, 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 and we're going to start with the fifth power, 5, 4, 3, 2, 1, all the way down to 0. Then we're going to continue with the value of b. In this case, the value of b is negative 4. So we have negative 4, negative 4, negative 4, negative 4, negative 4, negative 4. And since on the first one, for the value of a, we went from 5 down to 0, now we're going to go from 0 up to 5. 2, 3, 4, 5. And there should be a plus in between each term. Now, you want to be able to double check and make sure that the exponents add up to 5. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is 5, so that's perfect. Now, I'm going to simplify each of those terms. So for the first one, I have a 1. X to the 5 power is x times x times x times x times x, which is just x to the 5th. Anything to the 0 power is just 1, so negative 4 to the 0 is 1. 1 times x to the 5th is x to the 5th plus 5. That will give me x to the 4th. Negative 4 to the first power, we just have negative 4. Multiply 5 times negative 4 is negative 20, x to the 4. Let's simplify the next term. We have plus 10, x to the 3rd. Negative 4 to the second power is negative 4 times negative 4, which is positive 16. Multiply 10 times 16 is 160, so it's plus 160 x to the 3rd. Let's continue with the next term. We have positive 10, x to the x squared, and we have negative 4 to the third power is negative 4 times negative 4 is 16 times negative 4 is negative 64. Multiply by 10 gives me negative Positive times a negative is a negative, 640 x squared. Let's continue with the next one, x. X to the first is just x. We have negative 4 to the fourth power. That is negative 4 times negative 4 times negative 4 times negative 4. That gives me 16. This gives me positive 16. So multiply 16 times 16, 36, carry 3. 6 and 1 and 3 is 9. 6, 5, 2. So I'll give me 256. Now I'm going to multiply by 5. Multiply by 5. Gives me 30, carry 3, 25, 28, carry 2, and that gives me 12. So 1280. So plus 1280x. And the last term, we have a plus 1, x to the 0, anything to the 0 power is 1. Negative 4 to the 5th power. So we have negative 4 to the 4th, one more to the 5th. So multiply, that gives me 256. So multiply by negative 4. 256 times 4, 24, carry 2, 22, carry 2, 8. So I'll give me 1022. That was 1024, correct? So let's multiply it out. 1 times 1 times 1024 gives me positive 1024. And that'll be my answer. So going back it in, if you were going to multiply x minus 4 5 times and just do the whole distributive property, the FOIL, over and over again, this will be your final answer. Now let's continue with problem number 2. Problem number 2, it says rewrite the following expression in factorial form. So you want to be able to rewrite it as 5 factorial. 5 minus 3 will be 2 factorial, and then multiply by the 3 factorial. Some of you guys are forgetting to add the 3 factorial here. Let's go and expand and simplify. 5 times 4 times 3 times 2 times 1. On the denominator we have, let's do the 3 times 1. 3 times 2 times 1 here, because that will cancel. And I still have my 2 times 1. So it gives me 20 divided by 2, which is 10. On number 3. Now remember that on number 2, you want to be able to simplify, expand it in factorial form, expand it, and then simplify all the way through. You should get a whole number at the very end. And you can simplify before you multiply together, so you can just get 10 at the very end. Number 3. In a high school, a student has an option of 6 foreign language. You can train for 4 different musical instruments. How many different ways can a student select a foreign language and an instrumental training? Select. That should be able to give you a clue that we need to be able to use choose. So first, we want to be able to select a foreign language. So let's go and select foreign language. How many foreign languages are available? 6. How many do we need to select? 1. And, so we need to multiply. Instrumental training. How many different instruments do we have available? 4. How many do we need to select? 1. Now remember, 6 choose 1 is just 6. Multiplied by 4 gives you 24. Problem number 4. In how many ways can 6 different books be arranged? So we have 6 books that we need to arrange over one another. If one of the books is an encyclopedia, it must be on the 2nd position. So let's assume that we can do the vertical, but let's go and we're so used to doing the horizontal line. We have 1, 2, 3, 4, 5, 6. We have rearrangement. 2 different ways of thinking about it is okay, the encyclopedia must be in the 2nd position, so we have here. How many different books do we have left? 5. So the answer will be 5 factorial. That's one way of thinking about it. Another way is, okay, the encyclopedia is in here. How many different books are left for this position? How many are possible? We have 5. How many for this position now? 4, 3, 2, and 1. Which is the same thing as 5 factorial, because there are 5 different books that you need to rearrange. So either way you think about it is fine. We have 6. That will give us 20. 4 times 5 is 20. And that will give us 120 ways. Problem number 5. How many ways can 8 singers out of 14 singers be selected to participate on a TV singing competition? Now, you are selecting. So you have a total of 14 and you are selecting 8. That should give you a clue that you need to be able to use the choose. We are selecting. Doesn't matter the order. We basically are just going to be selecting 8 at a time. So we have 14, choose 8. From here we expand 14 factorial over 14 minus 8 is 6 factorial multiplied by 8 factorial. Let's expand 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial. Must stop here because that will cancel with this 8 factorial. You can continue if you want. And then the 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Now let's go and simplify very carefully. We have the 6 and the 2 cancels with 12. The 5 cancels, simplifies the 10 to a 2. The 3 simplifies the 9 to a 3. The 4 becomes a 2, reduce it with a 14. And the 2 cancels with the 2. Notice that all the denominators should be cancelled. So now we just have 7 times 11 times 13 times 3. So let's multiply 7 times 3 is 21. I'll do it on the side. I'll multiply the 7 and the 3, that's 21. I'm going to multiply by the 13. Times 13, that's 3, that's 6, that's 1, that's 2. 3, 7, 2. Now I'm going to multiply by the 11. Times 11. So it gives me 3, 7, 2, 2, 7, 3. That's 3, that's 10, that's 10, that's 2. So there's a total of 3,003 ways. Now let's continue with problem number. So in this case, the answer for number 5 was 3,003. For number 6. On problem number 6, it says determine how many different 3-digit zip codes are possible if digits cannot be repeated. Now remember the digits. How many digits do we have total? We have a total of 10. So let's go and see. We need only 3. 1, 2, 3. How many digits go here? 10. How many digits go here? 9. And in here, 8. Because they cannot be repeated. So now we have 9 times 8 is 72. Multiplied by 10 is 720. There's 720 different ways that we can have 3-digit passwords or zip codes.